Alright, so here we are in this video. We're going to take a look at the imaginary numbers and how to multiply and divide. It's not too bad, really, once you get used to it. But the very first thing we've got to do is talk about multiplying i's. And so we defined I as the square root of -1. Well, then if we square both sides, then I squared is equal to the square root of -1. And then we square that, which just undoes the root and gives us -1. If we continue this process, something funky happens. I cubed ends up being the square root of -1, and that's cubed. That's a little cumbersome. So we kind of split that off and we say, all right, well, that's really just the square root of -1 squared times the square root of -1 to the first. That's using those exponent rules. And so this is that the sum rule, the product rule, is where if you multiply two things that have the same base, you essentially add their exponents. We're splitting that up. We're using that to split this up. Well, we already know that the first thing is -1. And so this becomes -1. There we go, -1. And then times, and anything raised to the first power is just itself, so square root of -1. So if you take a look at this, then square root of -1 is I again. So this is really just -I. And then here on the final one, I to the fourth, there's an easier way to do this one. If we can recognize that I to the fourth, according to the rules, is really just I squared times I squared, or I squared squared, either one. Then what you'll notice is that we have -1 times -1, and that gives us a +1. You're like, oh, okay, it's not really all that cool. Now the fun happens. I to the fifth. We can split that up to I to the fourth times I. But I to the fourth is just 1, so it's 1 times I, which is just I. I to the sixth is I to the fourth times I squared, which is just 1 times -1, which is just -1. And then we have I to the seventh is I to the fourth times I cubed. That gives us 1 times -I, which is just -I. The other negative. Come on, negative. There you go. And then I to the eighth is really I to the fourth squared, because then that means you multiply those exponents. And so that gives us just 1, because it's 1 squared, so it's 1 squared is equal to 1. Now, again, it might not seem all that cool, but if you look, we have I, then -1, then -I, then 1. Then I, then -1, then -I, then 1. And the very nice thing is this process repeats. This particular method is, or this particular it's not really a function yet, but it's trying to be. Not as we would normally see a function at the real numbers. But this is a function. It's called cyclic, meaning that it cycles every so often. Your normal analog clock, the one that actually has the hands, because we don't see any of those anymore. But the one that the hand clocks, they are cyclic as well. There are some clocks that are 24 hours and they cycle every 24 hours. But most of the clocks are 12 hours. Every 12 hours they repeat themselves. The only reason that we know if we're in the afternoon or the morning is that we assign an AM or a PM to it. That is the only reason. And so that is a cycle. There are lots of cyclic functions out there. This just happens to be the first that most people tend to see outside of your clock. And so because of that, we can actually make a generalization. And that is that if you can rewrite I is equal to 4 times some number, we'll call it K, whatever that is, and then plus some remainder. All right, K is equal to 1, 2, 3, and it goes on forever. This is basically any natural number. All right, so that's a natural number, but we're really looking at R. This is really I to the R, whatever that happens to look like. So one way that you can work with this is you can just simply divide it by 4. If I just take an example here, like I to the 93. What I can do is I can just take and divide 93 by 4. I really don't care about what the quotient is. I want the remainder, because the remainder will tell me the power on I. And so this goes in there twice for 8, subtract 13. That goes in there 3 times. And that hits for 12, and this 1. So this has a remainder of 1. So it's going to look like I to the first, which is just I. And so that's how you can find any power. So that's multiplying the imaginary unit I. Okay, so now if we extend this now to the complex numbers, we can take things like 2 plus 3i, and we can multiply those with, say, 4 minus 8i. Well, to do this, and I don't say it, so I'm just not going to. But for those of you that have multiplied binomials before, this is your dirty 4-letter F word that I refuse to say. So you take this and you just distribute through. You're distributing. Shh, don't tell anybody. All right, so if we distribute this through, we have 8, and then we have minus 16i plus 12i minus 24, and then we have an I squared. But now we know the value of I squared. So if we clean this up, it's 8. These two things combine, because they're like terms, to be negative 4i. And then over here, I squared is equal to negative 1. So what we really have here is negative 24 times negative 1, which is going to give us a plus 24. Cleaning that up, we have real number components here. Real number components there. So we get 32 minus 4i, and that's the answer. So could you do this in an 83 and an 84? Yeah, you could. It's when they're like this, it's almost easier just to do it by hand, but you could. So let's take a look at that. And so we want to do this in the 83. The 84 works the exact same way. So we're going to have to put in parentheses just like we show here. So we're going to put parentheses in the the other 2, the kind with a 2, 2 plus 3. Now the I button is done by second and the decimal point down here. And if you look really closely, you can see on my calculator just below the 2 is a little yellow I. On your 84, it's going to be blue, but it's still the same thing. And it'll put it in there. And then you close that off, open the other set, and it's 4 minus 8i. And then you hit go. And it'll just do it for you. This is an option, but it doesn't always work. And here's an instance where it doesn't work. For either of these calculators, they have a certain problem. They can't do radicals. Whoops. And so, wow, that was bad. So we have, like, say, square root of 3 plus 5i, and we want to multiply that by 4 minus root, or sometimes I roots of 5. All right, whenever you have a radical, it's fairly common to put the I in front. That way it doesn't look like the I is inside the square root. If I goes inside the square root, we get a whole different ball of wax going on. It no longer becomes somewhat simple. Okay, here we just do it the same way we did last time. So we just go ahead and multiply those out. Now I have 4 roots of 3. And then over here I have the square root of 3 times the square root of 5. We can combine those so we have negative I roots of 15. We cannot reduce that because there's no square factors that would be factors of 15. And then we go ahead and we take this 5i and we distribute that as well. So we get plus 20i. And then we get minus 5i squared roots of 5. Cleaning it up, we notice that we have an I squared, which is really negative 1. So it changes that sign. So putting these together, and this is a real component. We have 4 roots of 3 plus 5 roots of 5. That's the real. On the back end of that, we have this plus 20i and the negative root of 15. So one way that we can do this is plus 20 minus the root of 15, all of that in parentheses, I. And it's customary to put the real part in parentheses as well, so that you stay within the confinement of a plus bi, which is the structure of the complex number. All right, so this all had to do with multiplication. You say, well, what about division? How can you divide these things? Yeah, we kind of fake it. Just as with radicals, and normally the powers on I and the algebras of I are done after you've studied radicals in general. And so if we were to take one, let's say 4 plus 3i divided by 7 minus 2i. This is really a radical down here. And one of the ways that you may have learned to divide radicals is you just go ahead and multiply by the conjugate. This is known as the complex conjugate. So we just simply change the sign on the complex part. Whatever the real part is, just let it be. Sing the song. And so this is going to be 7 plus 2i, both top and bottom, because you don't want to change the value of the fraction. And then you're just simply going to combine these just like we did up top. So I'm going to distribute here. And when I do this, I'm going to distribute and I'm going to try to confine everything all at once. So I'll explain it as I go. We have 4 times 7 is 28. 3 and then our other real component comes from the I squared. So I'm going to take the last. This is the L of your dirty 4-letter F word. But 3 times 2 is 6. I times I is I squared. 6 times -1 is -6. And then if I go for the inside and outside, I get 21 on the inside, 8 on the outside, and if I add those two together, I get 29 i's. Down below, you will always end up with the sum of squares. This is one of the reasons why you couldn't factor the sum of squares before. We didn't have the power of I. And so if I do this out, this is going to be 7 times 7 is 49. If you look here, -2i times 7 and a positive 2i times 7 is going to give you 14i and -14i. Those two will eliminate one another. What you're left with is -2 times 2 for -4, but I squared is -1, giving you a positive 4. Cleaning this up one more time and separating the fractions out so that we look like a plus bi. Remember, we have to look like this. So we have to have a real portion and an imaginary portion. We're going to go ahead and clean this up and say this is 22 over 53 plus 29 over 53i. And again, your calculator can do this. It becomes kind of a pain in the butt to put it in, but you'll get the hang of it. You always want to put parentheses around the numerator and denominator when you have sums or differences. That way it keeps the order of operations. But 4 plus 3, second, and then the decimal point, and then divided by, and in parentheses, 7 minus, use the blue minus, not the white one, minus 2i. And now you see we get decimal points. Just go to math, hit enter for change this number to a fraction, and hit go, and it'll display it. So 22 over 53 plus 29 over 53 I. The I does not go on the bottom here. It always goes out to the side. It's always multiplying the entire fraction, even though it doesn't really look like it sometimes. But that's really it. That's all you ever do for division. You just simply multiply by the complex conjugate, change only the sign of the complex part. Don't bother with the other. It's only going to cause more confusion. And so, anywho, this does it. That's it. Yeah, there's nothing more complicated. If you happen to have radicals in the bottom, those radicals will end up canceling out, because when you square a radical, then you're gonna go ahead and eliminate it. This only works in square roots. It does not work in cube roots, fourth roots, that sort of thing. Some more complex ways have to be done for those. All right. Well, I hope you enjoyed the video, and I hope you learned a little something.